Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The solubility of a salt, Zwitterian pair, in methanol depends on its stereochemical relationship, specifically whether the cation and anion components are enantiomers or diastereomers of each other, and whether the overall salt is a racemic mixture, a mesocompound, or a pair of diastereomeric salts. Two salts have identical solubilities in methanol if they are enantiomers of each other, mirror images, since enantiomers have identical physical properties in IChO solvents like methanol. Moving on to the next step. Identify the structure of each salt as a combination of a cationic ammonium component and an anionic carboxylate component, both derived from the amino acid PHCH, NH2, CH3, i.e., alpha-methylbenzylamine alanine analog, 2-amino-1-phenylpropane or similar. Moving on to the next step. Analyze salt I. The cation has configuration, central C with pH, H, CH3, NH3+, assign R or S. The anion has central C with pH, CH3, CO2, H, assign configuration. Salt I represents one diastereomeric combination, example, R cation paired with S anion, or a specific Rupees combination. And for the final step, analyze salt 3. The cation has pH, up, NH3+, left, CH3, right, H, down, and the anion has pH, up, H, left, CH3, right, CO2, down. Comparing salt I and salt 3, the wedge-dash arrangements of both the cation and anion in salt 3 are the mirror images of those in salt I. This means salt 3 is the enantiomer of salt I. Since salt I and salt 3 are enantiomers of each other, every stereocenter in the cation and anion is inverted. They have identical physical properties in an IChO solvent such as methanol, including identical solubilities. Check other pairs. Salt 2 has a different connectivity arrangement, NH3+ on top, pH on right for cation, H on top, pH on bottom for anion, making it a diastereomer relative to salt I, not an enantiomer, different solubility. Salt 4 similarly is not the enantiomer of salt I or 2 in the same way. Options A, C, and D involve pairs that are diastereomers and thus have different solubilities in methanol. Therefore, the correct answer is B. Therefore, the correct answer is option B.